Certainly. Well, the first thing to relate to, I guess, in this particular model, which is the DB4, it's our Formula Atlanta car. It's very similar in type of construction to a current Indy car, or a Formula One car for that matter. It's the chassis is made out of a combination of honeycomb and carbon fiber. It's glued and riveted together. Very rigid package. The aerodynamic package is basically a ground effects car with full tunnels on both sides, generating 1.5 to 2 times the weight of the car at speed.
That much?
Yes, and uses adjustable front and rear wings, and has very large tires for the amount of weight in the car. The car only weighs about 1,000 pounds.
Very light.
This particular car uses the 1600 4-valve Toyota engine that you find in the MR2. And
like you say, is the proving ground for Indy or Formula One.
Right. It's a proving ground for the driver and the designer. We like to think we've got a really nice piece here. He's taken the rule book and built the ultimate machine that they would allow us to build, which is using all the high-tech componentry and latest state-of-the-art design. It gets a lot of looks even in the IndyCar paddocks from the big car designers, and someday we hope to design an Indy car here in maybe the next 2 or 3 years. No, we don't have anything right in the immediate burner, but the first project for Swift right now is to get an engineering facility together. We'd like to build our own wind tunnel, and that's the place where the car has to start. It has to start at the engineering level before you can move on, and so once we get that done, then it's on to the next project. Swift Company's been in existence since 1983. It was formed by a bunch of racing enthusiasts that basically started a sub-S corporation to fund the first Formula Ford. This is actually the 4th model that Swift has done.
Right.
The company changed hands last year. Myself and a couple other of the original Swift people took it over when R.K. Smith, the past president, decided he wanted to go off and pursue his own racing career.
Right.
And so we're in the process of redoing some of the models and looking towards the future, and it's obviously a very competitive business. It's just like the racers themselves. It's just as competitive.
Maybe you could show us what is in the inside of these cars.
Sure, I'd be happy to. It gets prettier the more you take the body.
Suspension has changed quite a bit in the last few years. In earlier racing cars, the suspension used to be outside in the airstream. As we can see now, it's changed quite a bit. Could you tell me more about this?
Certainly. The primary reason for most of the changes on the car from 10 years ago is a completely different aerodynamic package that the car requires now, and that is the ground effect tunnels need as much clean air in through them as they can get in order to be as efficient as they can be. Therefore, all the componentry needed to be packaged in a different way to get out of the airstream. So all you've got basically in the airstream under the car here is a push rod and a bottom A-arm. We've even gone to the lengths of putting the top A-arm above the tunnel up here and laying the shocks down on top of the gearbox and the engine adapter in order to clean up the air under the car. It also makes for a very efficient weight distribution package because it's all tucked right in the midline of the car. You don't get a lot of weight transfer, and the springs that you end up running with the car with this setup are so stiff that you can't use a conventional rocker arm suspension anymore, because you end up having to build such a big unit to take the weight of the car, because like I say, once it gets rolling, not only weighs 1,000 pounds, it weighs 2,500 pounds because of the downforce that it creates. So that's the major feature in this suspension, is to clean up the aerodynamics, and we feel we've done a very nice job of this. As you can see, it's packaged real nice, and this one's got a few ideas on it that nobody else has got in the Atlantic right now.
As I see, even the control arms themselves are they're aerodynamically shaped, almost like an airplane wing.
Yes. The attention to detail on that stuff. No one thing maybe really means a lot. Each one is an insignificant, but when you add up 15 insignificants, you've suddenly got a significance. So the air tube suspension, yeah, that's part of the package. You also end up with a very narrow chassis when you're going for the widest tunnel that you can get, so a very stiff chassis is important also. And the engine is all tied together as part of the chassis now. You can see the top plate here mounts to our own cast cam cover, and the oil pan is also something that we made custom just for the car, because it ties in the bottom. So there is no chassis down there. The motor is part of this, is a fully stressed member. Makes for a very rigid package. Makes the car more tunable, keeps the chassis flex down, etc. So there were quite a few detail changes we had to do. Now this Toyota engine being different than the Cosworth, it took 182 part numbers, I can tell you, because I did the pricing
Right, fun.
to convert it over. Yeah, it's not just the basic stuff; it's everything underneath also.
Right, and the front of the chassis is mostly aluminum monocoque, honeycomb.
Yes, the top half from here up is a carbon fiber. From the bottom half, it is an aluminum honeycomb, all one piece bent up. The two are the honeycomb is routed out, and the carbon fiber slides down in that channel and is glued and riveted in place. And it has magnesium bulkheads front and rear, and the roll bar structure is all tied in. So when it's all said and done, the last twist test we did, it has about 7,500 pounds of torsional stiffness per degree, which is very good for a car this size. Yeah, very good.
How long does it take when working on a car to start from scratch to have it on the track?
From scratch.
Somebody's idea.
Let's put it this way: it takes about 350 man-hours to build a tub, just the tub. The rest of the componentry I'd be guessing at, but when we deliver a car to a customer as a rolling chassis, which is basically the car assembled with all the instruments in it and everything pre-assembled but not finally put together, you're still looking at, I'd say, 80 to 100 hours to make it race ready. Then they probably take 100 hours every time you run them too, to really go do them right.
There's a real attention to detail, like any little flaw could cause a potential accident or cause, whatever, a mishap or just, breakdown in the track.
Yeah, right. It's like an airplane flying on the ground. I mean, in fact, we have to meet a lot of the same specifications as the FAA does. Everything is safety wire drilled, Loctited, or there's some locking mechanism for each nut and bolt on the entire car. We have a rigid set of checklists and nut and bolt checklists that we do between sessions, and a real maintenance program that you have to maintain with one of these cars, because they won't run themselves. You have to really stay on top of them.
How big is your crew? Just how many people do you take on the road?
We usually have about 3 guys per car on the road, and 1 guy that's responsible for the car between races. That is really his baby, to make sure that everything gets done. But
so I guess you get along pretty good together.
Oh yeah. Yeah. We never a dull moment with all this, especially when there's 3 of us sharing a room and everything. Yeah.
Keeps each other tuned up.
Yeah, it's a lot of circus life. It really is. It's fun. We enjoy it.
Maybe we could move around now to the front of the car and take a look. Okay, we're now looking at the front of the Swift DB4, and it's a very interesting car. We just finished talking about the back, and maybe you could tell us about the front here. What is really important on the front of a racing car?
Well, the front end of the car, the way it's designed is pretty much the same reason that we had to do the rear end that way, is to clean up the airflow to the side pods. The side pods need as much clean air as they can get in order to function properly, so everything is aero tube suspension. And the only thing that's up here is what has to be here. I mean, you got to have a bottom A-arm and a top A-arm, and the push rod to actuate the shock absorber. The shock absorbers are down inside here, running this way alongside the driver's legs, operated on a bell crank. The air induction system that we've done is rather unique in that we've got this large fiberglass air plenum that runs along the side, inside the side pod itself, negating the need for an external air box, which just means more clean air to the wing.
I was impressed by that. Looking at this year's, like the Swifts, it's not sticking out there. It looked kind of ugly, and I like beauty in cars. It's symmetrical, this car.
Right. Sometimes the form follows function, and in this case, it really did. In fact, when we get we're working on a new tail for it now, where we don't even have to have the bubble in the tail for the carburetors, because the Toyota carburetor sits so much lower. So that'll clean the car up quite a bit too. It has very large ventilated discs up here with magnesium calipers for brakes, and really quite a sophisticated little piece. The nose box in here is just a crushable structure for impact, and you get a good view of the carbon fiber top here. This is the magnesium bulkhead I was talking about earlier. This is the anti-roll bar here, adjustable by just pulling the pin out and sliding it back and forth.
That's handy. Yeah.
Yes.
Yes, you want most of these adjustments to be right there. The car comes into the pit during a practice.
Yeah.
The driver, I mean the mechanic just takes his screwdriver or whatever he has, just turns something. The driver goes out for a couple of laps and he says, it's okay, no, that's not the right thing.
Yeah, right. In fact, the rear bar is adjustable from the cockpit. The front one we may do that a little bit later on. We don't feel it's quite necessary right now, but yeah, adjustability is the key in this racing because fine little adjustments can make a big difference on the racetrack.
So when they say dialed in, they literally mean dialed in.
They literally mean dialed in sometimes. There's actually a dial for the brake pads even. So, in fact, if you want, I can show you the cockpit here and you can get an idea.
Why don't we proceed and take a look at that?
Okay. Okay. Well, here we are with a view of the rather snug confines of the cockpit itself, but luxury is not a premium here because the driver has to live with whatever the designers left him. The width of it is actually the top part of the chassis, so there's no adjustability there. The steering wheel is adjustable fore and aft, and so is the shifter, which is this knob right over in here. This knob that you see here is the actual sway bar adjuster for the rear that I was talking about. And to get in and out of the car, you actually have to take the steering wheel off, you know, to get in and out. This is an electronic tachometer that we use that's the same that you'll find in an Indy car. They're very good tachometers. Then you've got oil pressure and water temperature and oil temperature also. Fire button is down here. That's only if you need it. And brake bias adjuster is over here. That'll cover the front to rear bias of the brakes themselves.
I'm quite impressed with the simplicity of all the gauges and dials. You don't need complexity when you're on the track. I believe a driver doesn't need that.
No, I mean you need the basic stuff. If something else is going wrong, chances are there's nothing much you can do about it anyway. Oil pressure and rev counter and water temper are really the big three that you need to know. Give him too much to look at, he's liable to go off trying to look at the gauges. So.
Right. And we were just talking there, it's all metal in the inside there on a cold rainy day like today. That driver's going to be aware of a little bit of temperature change.
Yeah, well that's part of road racing. I mean you got to deal with the elements. If it rains we race. I mean that's that. We don't reschedule the race or anything. So so drivers, yeah, sometimes they don't. It's not all as glamorous as it looks. They got to get out there and get like a duck or something. But.
He's not asking for a heater yet in the cockpit.
Not yet. Well, actually, they do make some particular suits that you can make where you can pump either cold water or hot water if you want on particular days. But it's really not necessary for this type of racing with the short distances that we run in the open cockpit. There's not that much heat generated.
He might ask out in Phoenix where it gets up to 100 degrees, he might be asking for a cool suit.
Yeah, that's going to be warm. We're going to go from one extreme to the other this week, I think, straight from here to Phoenix in only 3 days, so we're going to have our work cut out for us.
All right. Well, I just want to thank you very much for spending this time here with us there, Bill, and I wish you guys success with your company and your cars. I'm really impressed looking at them, and it's just it makes me fall in love all the time with the cars, you know, just continually. So thank you very much for your time.
Thank you. Maybe the next time we'll see you, it'll be at the Brickyard.
Yeah. Okay, so you take good care.